All right. Good morning, good afternoon, and good evening to everybody out there in YouTube land. This is Michael Redlick coming to you live from Flemington, New Jersey. Happy to be moderating Eric's and Oleg's presentation on non-deterministic. No problem. You can test it. So this is, welcome to day 2, session 1. And without further ado, guys, take it away.
With no internet, and as I was driving my son down the street, I noticed these 3 utility trucks digging a big hole in the ground with wires sticking up, and then I got a text from my internet provider saying, "Oh, we're doing work in your area today. You may experience internet connectivity." So I'm driving all of this off of my phone's hotspot. So what could possibly go wrong, right? We're going to keep our fingers crossed. So if I seem to disappear, Mike said that he'll come back on and say that I was kidnapped by aliens or something, but then I'd have some more explaining to do. So I don't know that I want to get kidnapped by aliens. But anyway, back to the content at hand here. So I'm Eric D'Andrea. I'm a Java champion. I live in New Hampshire, so I'm on the East Coast of the U.S. I work for IBM. I'm a software engineer on the Quarkus and LangChain4j projects, Dockling the Java. I help run my local Java users group here in the Boston area. I love cats, and he was just here a second ago. Love boating, black belt in martial arts, so love to do lots of different things. I've also written a book, which has absolutely nothing to do with what we're going to talk about today, but it's shameless self-promotion, right? We can't go live and not talk about our own things, right? So looking at Spring, or looking at Quarkus through the lens of a Spring developer. So it's a whole nother side of me that if you're interested in Quarkus and Spring, feel free to give it a read. And then I've got my partner in crime, Oleg, here, and I'll let him talk about himself.
Hi, everyone. Hi, Eric. Thank you. So I'm also surprisingly a Java champion. I work on the DevRel team at Docker, and being sort of the subject matter expert for all things AI. So I was a Java developer for a while, then I was more on the marketing side of the things. And now with the rise of AI, anyone can be a developer, even yours truly. I'm a mediocre chess player and allergic to cats, so I'm very happy that we're making this over the internet. So there's that. And together, we would like to talk about AI.
Yeah. So I guess what we're hoping to talk about, or what you're going to leave with here, I think we don't have all the answers, right? But I don't know about you. I like coding. As software engineers, we need to learn how to use AI. But as this AI thing evolves,
I think we are experiencing some network.
Am I dropping
troubles.
off?
I think so. Can you try with maybe?
All right, am I back? Am I back?
You sort of are back. Try lowering the video settings, maybe, or.
Yeah, I'm going to turn my camera. As much as I hate to do this, I'm going to turn my camera off to save bandwidth because, like I said, I am doing everything through a mobile hotspot. So.
Right, but since the internet monsters ate your remark here, right? Are we claiming to be experts and knowing and telling you, instructing you how to build applications that include AI components? Which certainly not. More and more, especially in the last year, people have been used to using AI agents locally for producing code, building applications, doing random computer work. But I think like as an industry as a whole, building applications that include AI components are still very much not explored fully, and also not explored by us, right? So we've built a bunch of stuff. We've tried different approaches. We're going to share our lessons. Hopefully, it will push you into the right direction, and it will make you think about what actually matters when you build applications with AI components.
Yeah, and I'm sure too, once we get to the end of this, there's going to be plenty of holes that people can poke that will end up looking like Swiss cheese, and that's okay. That's kind of the whole point of this, is to get you get people thinking about the things that need to be thought about and that I find are gaps in the industry right now. So I guess the fundamental question that kind of drove me to loop Oleg in and thinking about this talk was, okay, AI is great. We have different ways we can evaluate prompts and whatnot, but from an applications perspective, the fundamental question is, if I push a new version of my application and that new version could use a different model or change the prompts or have more tools, or it could have 5 agents, there's lots of things that could happen here. But did the thing get better or worse is the fundamental question here. And by the end of this talk, I'm not sure that we're going to answer it, but we're going to throw out some tools and some tips and technologies and different things that can help you try to get to this. Because I don't know that anybody, and if you are, please say something in the chat there. If you or can already answer this question, I would love to talk to you. And Oleg and I are going to be at JFocus in a week and a half, so come find us, and we would love to talk to you about if you can answer that question, how you're answering it and what tools you're using. But if we think of what's been happening, I mean, I've been in software engineering and in the software industry for a few decades. And over not just the last 6 months, but the last couple of years, I've never seen the pace of innovation as to what it is now. Oleg and I, when we first put this talk together about a year or so ago, it was all theory, right? All we had was slideware and some ideas. And then fast forward a few months and we had some stuff to show, and fast forward another few months and things are just exploding all over the place. So like everything that we say and everything, if you're watching this talk 6 months from now, it may be completely irrelevant. Who knows? Hopefully not, but there may be new things.
The fundamentals will not change. And the fundamentals are, even in the fast-paced world, is we are moving in a direction. Right. So if you watched this talk or you thought about AI last year, since last year, there was a lot of direction towards standardization. There were a bunch of protocols and competing standards created and introduced by different companies or combinations of companies. And the AI applications went from sort of chat interfaces to more AI with tools via the MCP, the Model Context Protocol, and then into organizing and orchestrating many different AI components into agents that have sort of, the plan and the agenda, and they can make a number of steps independently. And then at a certain point, it all went agents.
That's kind of where we are now, right? Everybody's talking about agents now.
There are a bunch of protocols also for connecting agents, right? So there is agent-to-agent protocol. There is the protocol how to embed your agents in other applications. There are protocols how to, I don't know, like there are a ton of them because everyone is experimenting. But the point is, it all becomes distributed, and orchestrating large systems where some parts are agentic applications or fully just agents running, having access to data, that is definitely happening. And that reminds us of something, right?
Yeah, kind of brings us back, for those who've been around for a little while, it kind of smells like something else that we used to do. We used to have this big monolithic thing, and then we had this breakthrough in DevOps, and things started to move fast, and so we broke them down into smaller pieces. So we can kind of draw some parallels to that, and we're all still kind of living the reality of microservices, right? And we've all read the microservices handbook. We're all familiar with when you should use it, when you shouldn't use it. People still agree or disagree on whether it was a good thing or still is a good thing. So your mileage may vary there, but we're still living that. Right?
But think about, so here is one point to think about. In the future, probably maybe now for some teams, agents will be like AI applications will be as ubiquitous as microservices. They're going to be more and more agents, agentic applications using AI for certain tasks that require some fuzzy computation. And they're going to be more and more of them. And I don't think we're going to revert this trend, at least for a while.
No,
so AI is here to stay.
Yeah. So if we take a look back, and this is kind of my own, you can agree or disagree with this, but from my experience over the last few years and working with this, I can kind of categorize AI, and you can't see my video, but I'm using air quotes here, AI into two different types. So I don't know if type is the right word about that, but I'm a developer, so I'm not really good at naming things. So I'm just going to call it a type of AI. So there's the type of, and this was kind of where AI first started to replacing the chatbots. Everything was the whole world of AI was chatbots. So you had this AI that was intending to either I don't want to say replace, but impersonate, replace, whatever. Again, I'm not good at naming things. So to impersonate or pretend that it's a human being. So think about all those chatbots you interact with, your favorite airline trying to get a discount on a ticket or whatever, Uber or Lyft, or the chatbots, and just think about over the last 2 or 3 years how they've evolved. They've gotten a lot smarter. Some have not, some have gotten dumber, but a lot of them have gotten smarter, and AI is replacing the functionality that would have typically been done by a human. It's actually interesting. I had to go through a car buying experience recently, because the whole separate story of why, and I don't want to get into it, but had to go through a car buying experience. You're going to all the different dealers and you're filling out their forms and you're chatting with these agents, and they look like or talk like real people. But at some point through the conversation, you start to say, oh, this isn't a real person. This is actually an agent. And then you can start to have a little fun with it, right?
Did they pronounce an M dash somewhere?
But then on the flip side of that, you've got the AI that's intending to replace or impersonate or behave like some piece of software that, as software engineers, we may have written. Think of the workflow systems, or you may have written a piece of software that did some organization or did some things, and now you're going to introduce AI or an agent or MCP or whatever to do this. And so that for me, that is a whole different beast from a testing perspective. And how do you interact with it, and how do you ensure it behaves? Because it's very different, and some of the practices might be or are probably different than how you would test or interact with something that's a chatbot, where you can't even begin to guess all the questions that may be asked of it, right?
Yeah. And if you think about this as not a trend or not something that is happening, then there are a number of examples where companies have been using LLMs for actually parts of their core software sort of business, right? And not even the state-of-the-art cloud LLMs to impersonate developers or so. But for example, Netflix taught a small LLM to do movie recommendations for a person, like a very core part of what Netflix value proposition is. And they just, instead of creating a machine learning model that certainly they can do, right? They figured out that training and fine-tuning a small LLM would be as applicable and as useful. And for example, Wiz taught a small LLM how to find secrets in code. So it's a security company, right? So they can scan the code and be like, oh no, that is the API key that you're trying to leak. And it is way fuzzier than you would expect with just it's not a regex, right? Like there are many ways to leak secrets in code somehow. And an LLM can be very good at finding and pointing a finger like, yeah, that is a code smell that probably leaks the secret. And Etsy, I think Etsy did the small LLM for the search query rewriting using your profile, right? So when you are searching for like ugly Christmas sweaters for a while, and then you would search for just a sweater or something, the LLM would take your profile and then would rewrite the search terms with your profile in mind. So text-based, very fuzzy. Can you probably replace that with a software, just normal software? Yes. Would it probably be worse? Yes. So this is definitely a trend, and it's going to get better and better, and we're going to get more and more applications this way. And us as developers, we need to understand how to work with this and sort of what is the evolution of our job that we require to undertake. So if you think about the past, sort of this microservices transition, right? We had the operations and developers teams, and then we had DevOps, and then we started thinking about security. So we got DevSecOps, and then some teams started thinking also about their cloud spend, and then so there was also DevFinOps, and then DevSec ML ops if you're doing traditional machine learning or running like models that are not LLMs. So we are gonna add the LLMs on top of this. So our processes, how we deliver software, will change. And so inherently, when you develop applications, right, whether you like it or not, you are practicing, you are somewhere in this DevOps loop, right? And the thing is, you might not do all those things consciously, but you are producing code and you hopefully are building them, and then you are somewhere in DevOps. So if you add AI to this, does it need to become like this monster of the process where you are not enhancing, you are exploding your DevOps cycle in size with the whole machine learning process, collecting data, validating the data, training or validating the models, feeding that into DevOps. This is unlikely the most optimized process, right? It's not what is supposed to happen when we add new technologies to our tool belt.
Right, seems kind of waterfall-ish, right? Where everything is tied together in a sequence.
Yeah, so probably we need to have a separation. So our DevOps will be still the same, right? It is ensuring that you put the things into production with a constant velocity, that there's a process how changes that you introduce flow into production, and hopefully also sensibly monitor and operate your environments. You have the sensible CI/CD process, which gives you confidence that your changes do not break production. And then separately to that, you probably have the machine learning engineers, your data scientists, your AI experts, maybe internal, maybe external as well, working on those machine learning models, those LLMs, and they go through a similar loop. They collect the data, they evaluate and build the data pipelines to feed only the best data into the models. And then they analyze and train the models through many iterations and versions and evaluate and understand whether the models are sort of good or bad. And then they deploy them somewhere, and then you use them in your applications. Is this good? Yes, it is good. Now, if your applications has AI and depends on AI, after all, you as a developer will be responsible for everything. Nobody cares if like OpenAI changed the model suddenly, or a company that you rely on had a sudden lack of GPUs and they had to throttle the model time for thinking of something, right? You as a developer are responsible for user experience of your applications. So you will need to understand parts of that, evaluating the models, or at least understanding how that is done. But you don't need to do that at every stage or every code change that flows through your DevOps pipeline. Let's see how this implements in practice, more or less.
Yeah, so let's talk a little bit about an application here. And rather than show it on a slide, I'm going to show a real live thing and what could possibly go wrong while doing this on my local hotspot, right? But luckily, and kind of the saving grace here is I actually stood this up in an external environment, so it's not actually running on my machine. So hooray to me for thinking about that. So if we have our typical chat bot, right? So we've talked about this application is built in the insurance domain. It's a domain that everybody can understand, right? So we have a crash that, Marty McFly was hit by Biff Tanner, And so we can start to ask the chatbot questions. If I'm an agent and I want to figure out what the right thing to do here, I could say, who do you think, who do you think is at fault? And we'll talk about the architecture of this in a second and how smart this can be. Hopefully the again, the network. So, based on blah, 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 Biff appears to be at fault for blah, 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 blah. So now I can say, okay, can you, so now it's under review. Can you update the claims status to approved? Right. So hopefully this doesn't take too long. It's doing something. It's thinking. So in this use case, I'm not using a local model. I'm just talking to I think the GPT-5 Mini, I think is the model that I'm using behind the scenes here. But you could start to think about, well, how is this actually architected? Is this all one application? Is it distributed? Is it agents? Is it MCP? Is there RAG in here? Is there tools? There's lots of different things that can happen or that are part of this architecture. Okay, so here we go. It was a little slow. So the claim has been updated to approved, and the claimant has been notified. An adjuster may still be assigned. Blah 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 blah. So as part of this thing that I've got running, the system that I have running, if anybody's familiar with MailPit, so kind of looking at different tools that you can use to help testing. MailPit is another one of those tools that's a great if you have to work with email. It's essentially a server that can get and send email and act as both a POP and an SMTP server. So here I have my application configured to point to MailPit. So whenever it sends email, I can now, as the developer, come in here and I can actually look at what it did. So here's an actual email, addressed to Marty McFly from the Parasol Company. We're writing to inform you that the claim has been changed to approved, blah, 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 blah. Sincerely, the department. And if you should you choose to reply, nobody, not even a bot, will see your message, right? So if you want to talk to a real human, call us. So that's pretty cool. And it seems pretty simple, right? But if you start to take and peel back and take a look at the architecture under the covers, again, you've got your, the thing that's representing the human. And of course, I'm talking with my hands here as if I'm on camera and you can see what I'm doing. But you've got the AI, the assistant that's interacting with the actual user on one side, but then you've got all this other stuff on the other side. And this stuff, whether everything is built into one application through tools, or whether it's using MCP, or whether it's using agentic for the points that we're going to talk about, it doesn't really matter like how distributed you make this or how many layers of indirection that you throw in front of it, right? The problem is still the same, because the underlying problem is the user is doing something and the user is expecting things to happen, and what you're doing under the covers almost doesn't matter. So right, you've got the code that you built here in the blue, and then in the space of AI, you've got this voodoo magic stuff that's in the is that orange or yellow, or the colors are all kind of messed up here. So you've got things that are guarding against, like when I want to send the email, the AI is actually generating that email, like the contents of that email that's not being written by a human, it's being generated by an AI. And then you need to validate it and make sure there's no, 4-letter words or whatever in there, that it's polite and all that fun stuff. So there's actually 3 or 4 different interactions with 3 or 4 different AIs or models that are driving this whole thing from start to finish. So that one, hey, can you do this for me? Can you take action on this? It's pretty
complicated. It's complicated. And
right.
If you think agents can make this easier and make it simpler, then it's not. So if you want to formalize this with agents for all your Haskell experts, it goes a little bit like this. When you're just using an LLM, that is your function AI, and it goes from string to string. So the API surfaces from text to text, which is not the best way to build software, especially if you believe into any sort of type system. And then if you add agents to the mix, so if you give them tools and they can do whatever they want with the external world, then it becomes the function from a string into something called IO string. And this, in the Haskell world, this very aptly named monadic infection. So we don't want a monadic infection in the architecture of our application. So we're going to limit ourselves to using LLMs directly as just the text processors. And even that is not that easy.
Right. What could possibly go wrong, right? Like we've already had things go wrong. Like we started this presentation off with things going wrong because, poor network connectivity. So what could possibly go wrong in an architecture like that?
Well, everything. So let's just look at what happens if we just think there is an AI application, sort of a vanilla AI, right? So it is called stringly typed. It is. It is called stringly typed.
If we wanted
it's likely even worse.
Is that true?
So anyway, so if we look at the architecture and if we squint a little bit, for most AI uses in our applications, right, we have the application and it makes queries to the AI, to the models, right? And on the architecture where we talk about boxes, it is very, very similar about how our application makes queries to the database, or our application makes queries to a remote service over the network, right? So the model could be anything. You could run it locally with Docker Model Runner, or you can VLLM or anything of sorts, and it's still for your application it's likely a query, unless you're actually building and running it within your Java binary. There is an external service, and you need to do the same things that you do with those other services, right? You will need to provision them somehow. You will need to have your CI environments with this pre-configured setup to use the correct credentials and URLs and everything. So can we treat AI as sort of a slow, inefficient, GPU-consuming, randomly answering you database?
Right. If I ask it the same thing twice, I get two totally different answers, which is not the case with a database.
Yeah, modern AI providers do cache your requests, so tokens at least, so you might get the same. But the point is, all of those parts where the application has this outgoing dependency on something, those are integration points. And the AI is no different in that sense. And we should treat that very, very similarly. So for example, if we have our tests that verify that our application can talk successfully to the database, we should do that the same with AI. And in some cases, this is fairly simple, right? So when your AI is replacing a whole human, then you can just sort of have this high-level end-to-end test for your application, which Eric can show.
Yeah, so I was going to show it live, but I have a bravo to me. I did a pre-recorded version just because you never know what's going to happen. So I'm going to just kind of play the recording. So as far as like the tools and the code here, I really like Playwright. It's a framework written by I think it's by Microsoft, isn't it? Does Microsoft have Playwright? But in any event, it's a framework for doing user-based testing, and it's available for lots of different languages. You've got there's Java and Python and whatnot. So if I go here and I run this, make this bigger. So you can see, so it does. So the other thing I like about Playwright is you can actually do recordings. So it can actually, as it's doing a test, you can see it's recording. It's actually running the app in a CI. It's invoking, and then it's disappearing. It's because it's going so fast. But I'm going to pause it here. You can see it actually pulls the app up. It finds the elements, and it's interacting with the thing as if it was a real person. So for testing or working with things where you're replacing a human, this is one tool or strategy that you can use. So
the irony is that on the back end of this, the assistant is replaced by AI, and on the front end of this, the the QA is replaced by, well, not entirely QA, but the manual human touching the UI elements is replaced by a playwright.
Yeah, and so playwright can actually interact and pop up the things and push in the buttons, and you could even get really cute here, like depending on what you want to test. If you want to test the hang on, yeah, my things are going over the place. If you're wanting to test the components or the application itself that it handles good responses, you can even back the AI with something simple like WireMock. So you might get the same response, but if that's not what you're testing, you want to test the interactions, or you want to test if the AI barfs, or if the AI takes too long, how does your application respond to that? You can use tools like WireMock. But if you want to start getting into, does my AI actually return the right thing, and do I care about what the AI is returning? That's where you can start, and we're going to show some more tools and techniques and things that we can start to use to leverage that. So normally, again, I would go in and show the code in my IDE, but being on my hotspot here, again, I have a slide that shows it. So if you're not familiar with Playwright's very easy to use, and it works just with, at least the Java version plugs right into JUnit, and you can do some pretty powerful things with not a whole lot of code. But
yeah.
But is that enough? Like, does that, so if that's one thing to test, but does that scale, and is that enough?
Yes, so that is unlikely to be enough, right? And the whole approach to tests, I think we need to rethink that, and we need to start from the beginnings, from the fundamentals, right? So we're going to run the tests, and it's going to be a process, and it's going to send us a signal, right? It's going to give us information about something. And the normal tests, right, for our normal applications, they have actually two signals, right? When the build is red, when the tests are not passing, when they're failing, it means that there is stuff that needs fixing. It may be your changes, or it may be some configuration missing, or it may be somebody else's changes, but something is not right. The expectations to the behavior of the application are not met in this test conditions. And on the contrary, the signal that we are very often ignoring, when the tests are passing, that should be a signal that we're confident to release. That takes discipline, that takes a certain level of effort, but because, well, if you don't have any tests, they will never be broken and red, and your build will always be green. But that doesn't mean that you're confident to release, right? So you need to have tests that verify the things that you want to verify. So those two signals, and then the purpose of those two signals are twofold, right? To avoid breaking production, avoid breaking user experience of your customers, and also to continuously improve your application and your development process. If we add more tests that are significant, this is a good thing. Next time something important will not break. Next time we will know that we can release with more confidence. So we would like to do the same for our applications with AI. And applications with AI do not just break when your AI vendor goes down, right? It's not just the integration point is wrong, right? It's not that we are not accepting the values that you put in the form and do not pass it to the LLM. AI applications break in a different way, maybe in a more visible and horrible way.
Yeah, you don't want to be one of these, right? One of these headlines.
Yes. IBM releases an agent that...
Shh, never. We'd never do anything like that.
IBM, actually. So shout out to IBM. They have very good local models, Granite models, open source. And if you're into that stuff, check it out. Didn't plan on plugging this, but since I mentioned IBM, I rectified my behavior.
Yeah, but essentially, so back to my car thing, I was really hoping this one up here in the top left that I could get the car for $1, but unfortunately that didn't happen. They've closed that loophole.
Did you ask? If you don't ask, you will never get it. Life advice. Listen to us giving life advice. If you don't ask, the answer is no. But okay, so let's think about what does failure look like with AI. And there are certainly two types of failures, right? There are the integration failures. The responses are too slow. The responses are not coming. The responses are garbled, or they have like wrong schema and so on, right? And this is easy to handle. This is the normal integration test. It's fairly straightforward. It's exactly the same as we do with the database, right? We can mock certain integration points. We can maybe spin up the real thing. We know how to handle those. And then there are semantic failures. And semantic failures are a completely different beast. It's when the result doesn't make sense. If you work ever in any sort of system where the database results need to make sense, or you are doing some sort of computation, then or you're building a compiler that takes lots of data in, and then it needs to produce an output that actually makes sense. Not just like there's not just the sort of the functional showing images stuff, right? Then those semantic failures are much harder to handle. And with the current toolset especially, right? You cannot mock the compiler because it needs to eat all kinds of code that you throw at it and return, well, maybe binary code or tree structures that make sense. That semantic is very important. So the normal integration test, like we saw with the playwright, that is not exactly the answer. We need something different.
Right. And so you need to be able to test for things and be able to handle errors properly and test for your error handling. So like this, just propagating an error, like a normal developer would just like log an error, an exception, or send it to your tracking system, but from the user's perspective, just propagating that back up and showing the error to the user is not a good user experience, right? So we need to think about, if we go back to these integration points and these patterns, we need to think about, well, what are kind of the things, the non-functional things around these integrations that are even the same or app-to-app communication. Things like metrics, tracing, observability, fault tolerance. These things become super important in these types of applications. Things are going to go wrong, and you need to be aware and you need to be able to deal with them. I like to think about these AI systems as a teenager. I have 2 teenagers, so I like to think of them as teenagers that refuse to listen or have selective listening. So if you think about trying to deal with a teenager and trying to get a teenager to do exactly what you want to do, nothing more, nothing less, then I feel like you start to get into a better place, because you can think about them. You as the parent think about your teenagers way more than they think about you, right? And a lot of these problems, we've already solved them when we start talking about observability and whatnot. So there's as we've shown with some of the tools already, there's lots of other different tools for trying to solve some of these problems. I alluded to like mocking or modeling services. You can decouple your applications from your AI. So if you're looking at the error handling side of it and you want to test the error handling side of it, there's tools and techniques and technologies for doing that. But it's almost impossible to get a model to return specific data, right? You ask a database, you can even pre-populate the database with data, and then you can ask it a question and you get some answers. But the models don't work that way. You can't like pre-feed the model some data and then say, just spit it back to me. You can try and maybe it'll give it back to you, but it's not guaranteed. So yeah. So what would happen if, to just kind of prove this point, what would happen in this? So this is some of the code for the system that I showed earlier. It has a system message and it has a user message. What if I made this change? What if I, as part of the user message, I took out a piece, and in this case, it happened to be the actual question that the user happened? How would I test for that? Obviously, it's not a compile failure, right? It's not like my app fails to compile, but what would happen, and how would I know that something broke, right? You need something that's watching and something that's evaluating this, right? Because I actually did this, and this was kind of the difference. So when you start to ask who is at fault, you get two very different responses. But is that an error? Like, clearly, like as you started to allude to, semantically, it's not correct. But from all your traditional fault tolerance and monitoring and observability, everything is green, right? Your system as a whole is, and again, I'm using air quotes here, working from a technical perspective, but the answers aren't correct, and that's something that we need to figure out how to do. So one approach to do that is to use, and again, throwing layers of indirection in front of things, is to use judging or LLMs as judges to do validation. And I will say this part, from about here on out, this is something I've been personally chasing for a while. And while I think today we have mostly some slides to talk about some of the ideas, just to kind of promo our talk at JFocus, we have a 90-minute slot at JFocus where we're going to revisit some of the stuff, but we actually have, that I'm diligently working on in the background, I'm going to have things to actually show, and like things that actually work. I don't have that today, unfortunately. So just to plug our talk for JFocus, which is similar, but it goes into a little more depth because we have more time.
Yeah. But for this simple case, of course, you can do this, and that works, and that's built into like Quarkus and all the frameworks. It's not that hard to imagine that when you have a test, you can have the validator that is an agent, right? That is an LLM, and you just instruct it to verify the claims, and you can choose how you want your LLM to verify things. It could be the Boolean gate, or you could ask it to provide you with a confidence, like as a number or in any other way. But you're in your test class path, you register additional services like this, and then your test looks very much like the normal test, which is you have your Quarkus test, and you inject your actual services, and you inject your test class path only validator LLM, and then you set up the conditions, execute your production code, and validate the response. So yes, an agent is telling you whether another agent is right. And you would think that this is like a little bit of a Ouroboros situation where like who is watching the watchers and who is telling you whether the validator LLM is actually sensible or not. And but the point there is very much so twofold. You decouple your production AI from your test AI. So those could be different, and you can have different requirements and budgets for those, right? So for example, you might want to use a local LLM for production customer-facing data processing, but your validator could be as big, as expensive as anything. You can throw the biggest, baddest, most capable model at it because you want to be very certain that it doesn't make mistakes. And it is called LLM as a judge. And it's a very frequent pattern whenever you want to understand or validate or expect some things from systems that give you non-deterministic results, you throw an LLM towards that. And then it's race to the bottom, because like you don't always have to use the most capable LLM as a judge, right? You can also kind of sort of dumb it down, because maybe like a capable local model is still good enough for being an LLM. Or maybe you can use a cheaper model. As long as you are trusting the outputs, as long as it gives you confidence, right, and you verify that it actually catches dumb things, you can lower the requirements for that. The point is that this is just like the normal tests, and we should be doing that.
Right. I say too, when we talked about this a few months ago, this whole concept of LLM as a judge was kind of like still taking shape. And I remember when we when we did this talk at Java Zone, someone raised their hand like, really, you're going to throw another LLM in front of it? And we kind of like shaking our heads. And now it's just kind of like the accepted pattern of practice, right?
Interesting enough, even in the using AI for development, it's very much the same, right? Very often you have another LLM to verify the, well, if you are using AI for developing code, right? You have another LLM to verify the results. You are cross-referencing ideas, and you're asking like, oh, another AI told me that this is the good implementation. Poke holes into it, right? And they mostly do, and the results are surprisingly usable. The problem is, of course,
yeah, go ahead.
Stupidity will always find a way, right? Sort of like life. And our main responsibility and our main purpose is that we need to know how to handle this stupidity gracefully.
Yeah, so the one like kind of like a teenager, the model doesn't always give you what you ask for. So like, hey, please return a JSON document that looks like this, and the model comes out and says, oh, sure, here, I'd love to give you some JSON. Here it is, and then mark tick tick tick, mark down. Here's the JSON. You know, obviously that's not what we asked for. Or from the model's perspective, like, sure, yeah, I gave you the JSON, but you gave me more than just the JSON. Just give me the JSON, right? So, you know, fun fact, you know, just for this particular example, there's tools that come out of the box with like LangChain4j and Quarkus and whatnot that just give you this protection for free, so you don't really have to worry about it. But yeah, but it's still a common. It's what I like to use because everybody can understand it.
Yes, that's a very common example, and there is a whole industry that is built based on prompts like, "Oh, please, LLM, I really need you. Make no mistakes. You need to get this right because my life is on the line and my family. I need to feed them. Please return the valid JSON or do the computation with no mistakes," which is, I think, that powering our whole agentic AI economy is very funny. That's this meme.
Right. And so we started alluding to, and I think Mario mentioned something, guardrails. So to me, and I've had this conversation internally with people as well. So when I think guardrail, my mind goes somewhere else because I wrote the implementation for LangChain4j, so I have a pretty specific thing in mind for how this works. So from a code perspective, in your application, you can build these guardrails, which are essentially functions that validate input and output of things, whether it's a call to an LLM, or in Quarkus, we now have the ability to guardrail around tool invocations or agent invocations or whatever. Essentially, you know, think back to your original set of patterns, you know, talking about the interceptor pattern, something that can look at the request before it goes out and then verify it when it comes back. And if it's not right, you know, going back to that JSON example, one thing that you could do is just have the LLM ask the same question again, and maybe you get a different answer. Or you know that, hey, this isn't valid JSON, but maybe if I can reprompt the LLM to say, hey, that's great, but please just give me the JSON and, you know, send it back and get it back, you know, that's a good thing. But there's also these some of the conversations I've been having is, well, could you do that? Think of like what service mesh is to Kubernetes, right? Where you can have things intercept calls. Could you do this at a higher level? And in some cases, maybe. In some cases, maybe not, right? So when we start talking about the guardrails, I always start to say that you don't want the guardrails to become part of your normal path. And I see the question. I'll get to the question in a moment. But guardrails are just that. They're meant to guard against things. So what happens, or how do you know if, going back to like that chat experience, you know, the eventual answer that comes back might be a decent enough answer, but if your guardrail had to run 4 times in order to keep reprompting your model to fix its output, that's probably not a good thing. And you're spending more money than you need to, and you probably have another issue, whether the issue is your prompting or your tools or something. There's something else that's not right, even if you eventually get to the correct answer, right? So if you remember, that one way to do that is, at the code level, is doing what we've always been doing, right? Using the tools we've always been doing. When you write these guardrails as code, you can test them, and you can test them with lots of different kinds of input to make sure that they work. But trying to understand, or are they becoming part of the normal path in a production system, is a very different beast, right? Because again, stupidity will always find a way through things that you build. So we need to make sure our apps handle this gracefully. And so part of that involves observability, and observability meaning the things that we're all accustomed to, the monitoring, the metrics, the tracing. But what are we measuring, and what are we doing? So we need to be able to collect metrics. We need to be able to track cost. We need to be able to track interactions. We need to be able to audit things. We need to be able to replay and rescore and stuff. So rather than showing this on a slide, I'm going to go back to my actual thing. And I built this Grafana dashboard. So part of what my app does is it's exporting, or it's computing as things are happening. And I think I did it more than 15 minutes ago. So I need to go back maybe to the last 45 minutes or last hour, right? You can start to see I've got metrics on this dashboard. And where are these metrics coming from? Well, I've got my total cost of all the AI that it's cost me so far since this app has been running. It's got some tool invocations. So you can see there's one tool here, and it's been invoked a few times. I've got my token counts, but the interesting metric is this average guardrail executions per interaction, right? So we can start to produce metrics from things like LangChain for J. LangChain for J already exposes all these building blocks. And this is what I'm currently working on now to make this better and to make this standard, is how do you actually track over time that, hey, I'm averaging 4 guardrail executions per interaction for each service. So I've got 3 different AI interactions here. They all have their own guardrails. So for the one that generates the emails, it's averaging the guardrails are having to run on average 4 times every time it runs, which is an indication that something's not right? My system eventually comes back with something that looks correct, but something's not right. And I can see, how many interactions I've had. So if I've had this generate email, and I don't know, something's not right here. It's not even showing on the dashboard, but essentially generate email ran a certain number of times. And if it's averaged 4 times, say it ran twice, and it's averaging 4 times per execution, that means it ran 8 times. So that's 8 back and forths between your app and the LLM with all the tokens and with all the costs that it shouldn't have had to do, right? If that makes sense. Oops, go back to my slides. Where did my slides go? There's the slides. Right, so being able to track this. Another part of this, and we'll talk about it when we start to try to answer the fundamental question, did you get better or worse, is the ability to replay, the ability, to score your interactions and to replay them, right? So being able to, as these interactions are happening, can you compute a score? Hey, you know what was asked, and you know what eventually came back, but how closely related is the answer to the question being asked? And then if you make a change to your system, being able to replay those same questions, maybe using some of the same tools we've already talked about, like Playwright or whatever, ask some of those same questions that have already been asked, gather the new results, and compare the results amongst each other to say, hey, did it actually get better or worse? And I don't have a live demo of that, unfortunately, at the moment, but I will by JFocus. So please come to JFocus, and I will be able to show that. And I'll even be able to show live on a dashboard, like a cool thing to show in a widget here is what's my scoring like per service over time. Again, I'm using my hands as if you can see me, but having a chart or a graph that shows, over time, this service has an average score of 85%. And so you can start to watch this over time. And if it dips below a certain threshold, then, I can try to see what happened. And I can see what happened because it's all the metrics are going to be tied together. If I go, for example, if I want to see if I saw that there was a dip in something, I can then come into my application and I can find that date and time. Last hour. Oops. I don't know why it's not. Oops. sorry. Could possibly go wrong on a live demo, right? Yeah, so I've got some traces here, right? And then I can look at the traces, and I have all the things between all the different systems. So if this, regardless if these were agentic or agents or MCP servers or A2A or whatever the protocol is, you still have a holistic view of the entire thing that the user did across different systems. And as we start to add this scoring mechanism in, even if that scoring is going to be done, which the short version is it will be done by a different system, that scoring will show up in this trace as well. So you can start to see or be able to click through from, hey, my score started to dip here. What happened? You can go back to the trace and you can actually get back to the actual requests and the actual user and all the logs of everything that happened at that point in time. So that's the story we're hoping to weave and have a little bit more to talk about or show next week. But unfortunately, I'm still working on it. It's not completely built yet. So I think we're starting to get close to the end. And like I said, unfortunately, I don't have all the answers and I don't have all the implementation yet, but kind of like we said at the beginning of the talk, that we weren't going to have all the answers. And if you are doing this today, like I said, I would love to talk to you. If you have answers and you have a paradigm or methodology or tools, I would love to talk to you. Reach out on social media or whatever. But essentially, all these things are building blocks. The observability is a building block that Java frameworks or your application framework should give you for free out of the box. The being able to track over time is something you probably need to build until something exists. But putting all of these things together, you have to be doing all of these things in order to answer that fundamental question about, am I getting better or worse, right? And could you actually fail a build? So could we use some kind of scoring if we are able to track the revalue in layer? CI, did I disappear for a second? My screen went blank. Am I good, Oleg?
You're good now.
Okay. So could we actually stand up our app in like a CI environment or a test environment, rerun all of the prompts or the answers, do a live scoring, and actually fail a build because our score dropped below a certain threshold, right? That's the goal. And unfortunately, I don't have something to show for that, but that's the goal.
And if you're thinking that it's enough to test the model and your AI experts or your ML team will just give you a better model, then you are not entirely understanding how this combination of your applications and the model is different based on the data that you feed, the prompts that you feed, the guards that is like this whole system is much like more complex than just systematically evaluating the model. And on top of that, you don't necessarily, as a developer or even as an individual project, you don't necessarily can control yourself what models you are to run. The decisions about the models are not even based on quality very often. It's very much the numbers game of what do we think is the most applicable and the capable model for the current tasks. Very often you are required to use certain models for tasks based on financial decisions or partnership regulations or something. So for example, if your CFO comes to the CTO and says like, okay, now we are switching to, for example, Google models, and then your selection is very different from maybe the whole world of picking which models you want to run, right? And sometimes you're lucky and you have the models where there are like both the commercial cloud hosted versions and then there's some sort of open source families like with Gemma and Gemini. Well, rather Gemini as hosted and Gemma as the open source local models. But for Anthropic models, very often, like you, for example, don't have the local corresponding thing. So, and the selections are not just even capabilities. Very often it's price, very often it's others. So you, as a person responsible for the applications, you need to be ready and you need to understand what happens when model is suddenly switched under your feet.
Yes, I actually have a good example. I was talking with a colleague yesterday or the day before, and he has on the Quarkus team. Clement Escoffier, one of the project leads, one of the things that we typically say is that Clement struggles or has to deal with these problems so that the rest of industry doesn't have to. And this is yet another prime example of that, where he has a bunch of tools that he's written or that are part of like the automation that we have on GitHub. And he switched the model from OpenAI to Gemini and just found that the results were awful. He had to go in and retune and rewrite all of his prompts. And now he says he's getting better results, but he's paying 2 to 3 times the amount that he was doing with OpenAI. So, kind of a similar pattern there to what you were just saying.
Yeah. And it's not necessarily in that direction. It might be you overtuned your prompts and your data layouts and structures for the particular models. It might be that you're working in a particular industry. It depends on the many, many factors. So, and the combinations of those are only available in your project, right? So you cannot, no one else can do this job but you. So you need to understand how to do this consistently within your DevOps process.
Yeah, and I think too, this is one of the reasons why software engineers are not going to be extinct in a few years, right? Because can the AI really do this for you, right? So if we start to think about some takeaways, I mean, I didn't really talk much about the technology stack here, but everything that I showed and everything that I built on is built on top of LangChain4j, and Quarkus just makes it work. But a lot of the functionality for the monitoring, the observability, and producing all those events, that's just comes straight out of the box from LangChain4j. I didn't really have to do anything there. So the core frameworks and libraries provide you the base building blocks for the underlying problems. It's just how do you assemble them together. I think we showed naming things is still hard, right?
And definitely you are still going to be building applications. At the bottom line is you will build and deliver applications, you will build software. So don't forget your craft. Just because your application uses AI for some components doesn't mean your DevOps process needs to be thrown out or needs to be replaced with ad hoc procedures. So you need to follow the best practices. You should write tests. You should expect the change both in the code and the external systems. You should expect the failure. You should be able to fix things often. You should be able to automatically determine whether things get better or worse and block bad decisions. And all in all, AI, if you squint hard enough, AI is just an API call. And you've always done that. You just need to tweak your point of view a little bit, and you just need to use better tools.
Yeah, I think that's about it. I don't know what happened to my ending slide. It's not here. Did we delete it? There it is. Yeah. I think we're done. And see if I can come back on camera here if the thing will let me. I think it was just too much. And so, yeah, these slides are available. If they're not there, if somebody tries to go and they're not there for some reason, just reach out to me on social media. They should be there. Yeah, I'm really looking forward to a week and a half from now at JFocus, because I think we've got a lot of cool stuff that can add on to this because we have a longer time slot. So I'm really looking forward to being able to dig into the weeds and show some stuff too.
Yeah, we're gonna look at some code. You can look at some code and everything in between. Thank you for watching. This was
All right. This was awesome, guys. Thanks for your time on that. I know we're a couple minutes over, but Max had a question a little while ago. I don't know if he's still here, but we'll show it, and for the recording, if you guys would like to answer that.
So do we think that spec-driven development is a way to mitigate the issues with prompting or models spewing nonsense back at you? If you are thinking about just using AI to develop applications where you have specs for what needs to be done, probably it might help a lot if you are using your applications, if you're using AI within your application and you feed it like sort of the system data, then it's unlikely to be enough, because the sort of the query that goes to an LLM, I think, so it consists of your prompts or like specs if you want to write them in a spec style. It consists of data that comes from the live system. It contains of the data that might be half missing and so on, right? So I don't think you can really overcome this by statically doing things before the application is run. Eric, what do you think?
Yeah, I mean, I think I'm trying to remember exactly at what context the question was asked to. I think, were we talking about guardrails?
Yes.
Yeah, so if we talk about guardrails, you think spec-driven development. So I think even having a spec, I'm not sure, like, I think I agree with what you said, that it would mitigate or eliminate some of these issues, because the model is going to do what the model is going to do at the end of the day, regardless of the structure. If that makes sense.
All right. Well, again, thanks everybody for joining us. The next session is already underway. Mario Fusco will talk about agentic AI patterns. So I will look forward to seeing you there. And with that, Eric, hopefully you get your internet back to normal at some point. If Murphy's Law had its way, it'll come back 5 minutes after this session.
That's probably what'll happen. But I know my phone's like hot as it's wicked hot right now.
All right, gentlemen.
Thanks
everybody again for attending today's session.
Bye-bye.